Today's lesson, we're going to talk about inverse trig functions. So this is the inverse notations right here. What does that inverse means? So let's say we have sine 30 degree, and we know that's going to be 1/2. The same notations, we can ask the degree this time. So if we wanted to ask degree, given the value, we could use the inverse signs. So this means, what's the angle when sine is 1/2 values, which is going to be 30 degree. And another thing it's important about inverse functions is they have a restrictions on the domain and range because it's not one-to-one functions. So you will see your sine inverse will have domain and range restrictions. Cosine will have that too. And tangent also. With that in mind, let's look at the example 1. So example 1, find the exact value of each expression between 0 to 90 degree, right? So before we do that, let's recall from the other sections. When we have 30 degree, you will have 1 square root of 3 and 2. 45 degree, you will have 1 and square root of 2. And then 60 degree, you have square root of 3, 1, and 2. If you don't remember or you don't want to deal with this memorizing these 3 angles size, then you have to memorize the charts. So if we look at the first one, which is sine inverse of square root of 3 over 2, what we need to do is your sine is look like that from the triangle. And this means you're going to have square root 3 right here, and you're going to have 2 right there, hypotenuse. And when you look at your 3 shapes here, the one that you have square root 3 on an opposite and 2 in hypotenuse, that's going to be 60 degree. So that's how you can find your solutions. Or you have to memorize the table, like I mentioned. So you have options, whichever method you wanted to do. But my lecture, I usually go over by the shape, memorizing those 3 shapes. Let's look at the second one. What about if they're asking cosine inverse square root of 2 over 2? This one, we need to rewrite this first because you have the same number numerator and denominator. The one on denominator do not have square roots, means that's because you rationalize it, right? So this could be the same as 1 over square root of 2. So before you rationalize. And you know that cosine should be look like that. So when you have a triangle, it should be 1 here and square root there. And that's going to be 45 degree shapes. Let's do tangent this time. Square root of 3 over 3. Same thing, this is equivalent to tangent inverse of 1 over square root of 3. And tangent look like that. So when you have a triangle, this should be 1, this should be square root of 3. That gives you 30 degree. Okay, so what about if you have negative value? Negative value, So first thing I will do is finding exact value before you rationalize it. So it will be negative 1 over square root of 2. And find the angle for it. So this is going to be cosine. And this should be 1. This should be square root of 2. So that gives you 45 degree. 45 degree. And at the same time, you need to look for negative. So negative in 45 degree, that's going to be cosine positive in the first quadrant, cosine negative in a second quadrant. And remember, when you're looking at the restrict domain for cosine, if you look at it, it should be 0 to pi. So the domain of cosine only can be first or second quadrant. And we know the second quadrant is the one that it have negative. So we will say 45 degree in second quadrant. How do we find 45 degree in second quadrant? It will be 180 minus 45. So that gives you 135 degree. Let's look at one more. You have a cosine inverse of negative square root of 3 over 2. This do not have the same value. So this is going to be cosine. On the bottom is going to be square root of 3 and hypotenuse will be 2. And if you recall, this is going to be 30 degree. And which quadrant? Because the negative, remember, cosine domain is first quadrant and second quadrant, and only the second quadrant cosine is negative. So again, 30 degree in second quadrant. And it means 180 minus 30 degree gives you 150 degree. Next two problem, you are using the calculator. So cosine inverse of 0.7, when you click on the calculator, you should be getting 0.795 when you round it. G, when you do sine negative 1, so sine inverse negative 1.2, on your calculator, you're going to get error message. The reason behind is because the domain being sine inverse domain is between negative 1 and 1. But it's over negative 1, smaller than negative 1 value. So this is not going to give you the angle. Composing trigonometric functions and their inverse. The most important thing that you need to remember is their domain, because the value have to be inside their domain in order to have the exact values. For example, if you have sine inverse inside your domain, your value had to be between negative 1 and 1. When cosine inverse is inside, you have to have domain. The value have to be inside your domain, which is going to be negative 1, between negative 1 and 1. So let's look at the examples. So when you're looking at the first one, you have a tangent inverse. And then first thing you need to do is see if 5.3 is inside of your domain of tangent inverse. Your tangent inverse is right here. It said domain is all real numbers. So no matter what value you have, that will be inside of your domain. So in that case, inverse and tangent cancels out each other, and it will give you exact value of 5.3. What about the next one? Sine inverse. So let's look at sine inverse domain. That's your domain of sine inverse. Let's make sure this value is between -1 and 1. 98 divided by 99 is going to be smaller than 1. So it is inside of the domain. So that means your value is going to be 98 over 99. This is going to be the same one, right? Because you have cosine inverse inside. Let's see, square root 2 is going to be a value that's inside of the domain of cosine inverse. Where's the cosine inverse? Cosine inverse right here. Your value had to be -1 between 1. And square root of 2. What's the square root of 2 value? Square root of 2 is about 1.41, which is outside of 1 domain. In that case, you will not have exact solutions, so will be no solutions. And if we're looking at rest of the example, your inverse is outside. When you have inverse outside, what you need to do is finding inside of value first, and then see if we can find inverse of that. So find the angle of that, right? So let me write that down. And D, we have sine inverse of sine 2 pi over 3. And we know that sine domain, where is the sine domain? Right here, which had to be between -pi/2 to pi/2, and this is the over pi/2. So this is outside of your domain. So when this is outside of your domain, what you need to do is using the reference angles to find this value. Once you find the value of sine 2 pi/3 using reference angle, replace it. So you're going to have sine inverse of whatever that value, and see if we can find the rest of it. So first thing we need to do is finding reference angle of sine 2 pi/3. And when we look at that in a graph, let's say this is going to be 2 pi/3. The reference angle is going to be this, which is going to be pi/3. Because when you're adding those two angles, it should give you pi. So then the reference angle of sine 2 pi/3 is going to be sine pi/3 in second quadrant, which will give you square root of 3/2. Again, pi/3 is 60 degrees, so that's going to give you 3 there, 1 and 2. Your sine will be square root of 3/2, right? So you're going to replace that value, this value, for square root of 3/2. Sine inverse of square root of 3/2 means what's the angle that gives you square root of 3/2? Well, what was that angle? Pi/3, right? So that gives you pi/3. Pi/3 in first quadrant. Why is it first quadrant? Because this value right here is positive. So when you're looking at the domain of the sine inverse, or sine right here, right? That's going to be that's sine inverse domain right there, right? Where first quadrant is positive and fourth quadrant will be negative. So in order to have positive square root of 3 over 2, pi over 3 had to be in a first quadrant. So that's going to be pi over 3. What about E? You have cosine inverse times cosine pi over 3, right? So first you wanted to see if pi over 3 is in domain of cosine. So cosine right here, pi over 3 should be 0 to pi. Pi over 3 is inside of your domain. So that means you don't have to do much work. Your solution should be just canceling out this cosine inverse by cosine. That gives you pi over 3. So long as inside of the domain given value will become your exact value because inverse and trigonometric function cancels out each other. When we look at problem F, this time we're looking at sine inverse times sine 7 pi over 6. The domain of the sine was negative pi over 2 between, right? And pi over 2, this is way over, right? What do we do in this case? Well, use the reference angle, right? So let's see if we can find the reference angle of 7 pi over 6. So sine 7 pi over 6. Let's see if we can graph that. That will be pi over 6 more from pi, right? So this is going to be a reference angle, which is going to be pi over 6. So this is going to be sine pi over 6 in third quadrant. And that's going to be pi over 6 is 30 degrees. So that should be the smallest side, and this is square root of 3, and this is 2. And your sine is going to be 1/2. In a third quadrant, that will be negative. So that means you're going to now find sine inverse of negative 1/2. That's going to be, well, 1/2 sine is always pi over 6, right? So that will be pi over 6. In which quadrant? Remember, when we're talking about inverse, right, your domain is going to be negative pi over 2 to pi over 2, which is first quadrant or second quadrant. And sine in first quadrant is positive. Fourth quadrant is going to be negative. So in order to have this negative, pi over 6 in the fourth quadrant, which is going to be negative pi over 6. When you're doing homework, this is the tricky ones. So I'm going to do one more. So let's look at the G, cosine inverse times cosine pi over 3. So pi over 3 is outside of your cosine domain. So then we're going to find the reference angle of cosine 4 pi over 3. Let's see, on a graph, 4 pi over 3 should be somewhere here. This is 4 pi over 3, and that's pi. So how far we're going further? Pi over 3 further from the pi. So that's going to be same as cosine pi over 3 in third quadrant. pi over 3 is 60 degrees, so we'll be square root of 3, 1, 2. Cosine is going to be 1 over 2. In third quadrant, should be negative. So now, we are going to find cosine inverse of negative 1/2. The cosine that gives you 1/2 is pi over 3. But also, in order to get negative, let's see what's the cosine domain, the inverse domain, right? So cosine inverse domain is this, where cosine is negative. In a second quadrant, cosine is positive in a first quadrant. So in order to have pi over 3 in second quadrant, because it's negative, that's going to give you 2 pi over 3. How do I find the pi over 3 in second quadrant? You do pi minus pi over 3, right? Now, example 3 is asking to find the exact value from the equations, trigonometry equations. So first thing you wanted to do is always isolate trig function by itself. So when we're looking at the first problems, it looked like you have a inverse trig functions, but that's multiplied by 2. So you wanted to isolate trig function by itself. So let's start by dividing everything by 2. So that 2 over 2 cancels out. You have cosine inverse of x is pi over 2. Then you're going to multiply both sides by cosine. Why do we want to do that? So we can get rid of cosine inverse. Remember from other examples, in order to cancel out the inverse, you need to multiply both sides by cosine, right? So you're going to multiply this by cosine. That means you're going to multiply this by cosine. So that cancel out, but what's remaining then? X is equals to cosine pi over 2. So what's cosine pi over 2? Pi over 2 is 90 degrees. This is pi over 2. And that point right here is 0 and 1. Since cosine is x value, that's going to be 0. Another way of looking at this problem is finding a value of that angle, right? Before you multiply cosine to get rid of cosine inverse. So just different way of thinking, but still the solution will be same. What about this one? The second one, it's more longer. So what I like to do is I like to put it all together. One with the sine inverse sign. I wanted to put the like term together. In order to do that, let's move around the like terms. So I will have 5 sine inverse x with 2 sine inverse x. In order to put it together, you need to subtract. So move this to other side of equations. So become negative 2 sine inverse x. And it means that without the sine inverse, I will put it on the right side. So negative 3 pi was there before, so let's move negative 2 pi to the other side. That makes it positive 2 pi. And when you combine This is the like term, so you combine 5 minus 2. It gives you 3 sine inverse of x. This is going to be like terms of pi, so when you do negative 3 plus 2 will be negative 1 pi. Now, this is similar to where we start the other problem, so let's divide both sides by 3 to isolate the inverse of sine on one side. And then basically, if you don't want it to multiply by sine to get rid of sine inverse, you are looking for the angle, right? I mean, the what do you call this is going to be exact value, right? Because the angle is given. But if you don't see that just looking at it, then what you can do is just let's multiply both sides by sine, so that we get rid of sine inverse. That gives you x equals to sine of negative pi over 3. And let's look at pi over 3. So pi over 3 is 2 square root of 3 and 1 sine, so we'll give you square root of 3 over 2, and we need to know if this is positive or negative. And because this value was negative right here, which means that's going to be sine negative. It's in the fourth quadrant. And fourth quadrant, this value in sine is going to be also negative. So for this reason, it had to be fourth quadrant. And in a fourth quadrant, sine is negative, right?